if we take financial sector or banking as an example, one of the things that the bank might be really, really concerned about is when giving out loan, how many of those people are going to pay back and how many of those people are going to default on their loan, which is not able to pay back. So that's where credit risk analysis comes into play. And this is what we're going to work through in this example. And we're going to do some classification, play around with some synthetic data and see what we can understand about how classification works. So let me just start off by importing these two libraries, and we'll create a random data set. And to this, I want to assign some defaults, and I want to have some sort of predictability in here so that we have some correlation between this default term and the credit score. So all I'm doing here is if the person is less than 500 credit score, we assign a random choice. And then if the person is higher than 700, then we assign some other random choice. And we're just going to play around with this and see what kind of default rate we're going to get out of this. So I'm just going to assign this function, and let's do default, and let's print out the synthetic data that we have. So far all we've done is create a synthetic data. There has been no machine learning yet, but let's analyze the data. So this should hopefully look similar to what you would get in a bank or a financial sector or any other open source data that you have access to when we are calculating credit risk. Of course, there might be a ton of other features like age, gender, location, other things, but for now we're just going with credit score. So we're able to see the credit score, the loan amount, and if the person defaulted or not. So this is a very simple synthetic data that we are able to generate, but let's also look at in terms of a plot, because sometimes this just tabular data doesn't make much sense, right? So we'll go back to our handy matplotlib, import that, and we are going to initialize a figure. We're just going to give it a default is red, and then not default, which is blue, which is also 0, is going to be blue. We are going to do a simple scatter plot. To that, we are giving the credit score and the loan amount, and for color, we are giving the default column, and then we apply a simple lambda function over here and assign it color. These two are X and Y labels. They are simple title and legend, and let me just do a plot.show. So in this plot, we are able to see this is the credit score, right? And whenever we have users who are less than 500-ish or 600, you see a lot more reds in this block over here, and then a lot more blues over here. And blue is no default and red is default, and this is the loan amount. So our data looks something that can be used in real world, and this might be something close to real world. So we're going to work with this and see what kind of classification algorithms we can understand and how to go about evaluating it and getting an intuition of how these algorithms work. So let me just minimize that. And the algorithm that we're going to use is a straightforward logistic regression, and we're going to go through some of the evaluation metric intuition, but for understanding the logistic regression, some mathematics behind it, I have a separate video on that. We can check that out. So let me just bring all these in. So first one is logistic regression. Second is just a train test split, where we have a set of data and we want to assign some of that to training set and assign some of that to test set. And in real world, you might also have like evaluation set, etc. But for now, test and train is fine. And then we also want an accuracy score. Here we are just defining X and Y. So X is going to be all our features that we want to give to the model, and Y is going to be our variable which we want to predict. So in this case, default is the column that we want to predict. So that is good. And let's split this data up, and we're giving 70% into our test set or training set, and then the remaining is going to be in the training set. So this is good. Let's run this, and it's as simple as initializing this function and doing a model.fit. And there we have it. We have a model trained for logistic regression on this credit analysis task. And let's also print out the accuracy. And for printing out the accuracy, we are going to predict, and to that we're going to pass in the test set, which we haven't shown to the model yet. And once we do get that, we are going to pass in the test set and the predictions that we're going to get. So the predictions are coming from here, and Y test is the actual observed data. And the difference between these two is going to give us an accuracy score of how well this model did. So let's run all of this. So we get an accuracy of 0.67. Now you might be thinking this is a really bad model for 0.67, but there are a few more metrics and evaluation tricks we can use when we're doing classification, because it's not as straightforward as just looking at accuracy here. So before we do that, let's plot out these predictions as well. And here we have a similar sort of a scatter plot, but then we are assigning an opacity and also an X mark over here. So you see these X's are the predictions, and some of them are also the actual values. So the predictions are in light color and the actual is going to be the actual red color over here. So this is good from an outset. It looks like it's done something, but what can we understand really from this task that we've done? Before we do that, all the confusion matrix classical report and other things, let's also do some predictions, right? Because we want to understand how this would work in real world. Now, regardless of if we have a good model or bad model, what is the output that we're going to expect when we have a data set like this? So we probably have some people who want to come into a bank and want to apply for a credit card or a loan. And for them, we'll probably have a credit score like this. And we also have a loan amount that they're looking for. And our job in this function is going to be to use that model that we've just trained and then assign a score or tell the bank if this person can be granted that loan or not. So that's what we're doing. We're just initializing a function, and all this does is gets the input data from the data frame, the credit score, the loan amount, and the default, and it's just going to run a predict function on it. So we can just initialize this again, and here is where we have a credit score and a loan amount that we want to predict, and let's run the predict function and see what we get. So here we say predicted default status for customer with credit score 600 and that amount is 1. So this person is going to default on it. So let's reduce this to, let's say, 2000 and see if this person is worthy of receiving a loan. So yeah, we get a 0, which means we can give this person loan, but it's we can do even more. So instead of just doing this, we can say recommended approval or not. So this is again the same function that we had above, but just looking at it a different way. So let me just run the same examples with this. So we say recommended loan approval with caution, and then if I just do like 2000 as the loan amount, then we get recommended loan approved. So this is good. So we have something working now. So we know how to go about getting the data and how to predict something and then use it in real world. So hopefully this can be like an API or something that you would call when the customer is just waiting for the loan approval. You can run all this in the background. So now comes the important part, how to go about evaluating if this method was good. Should we go for some of the alternatives like neural network, XGBoost, other classification algorithms out there? So how do we actually know that? So that's where we have the confusion matrix and the classification report, right? So simple, let me just go through this. So here I have a confusion matrix, and here we have two axes over here. One is going this way and the other is going this way, right? So this is the matrix that we have over here, right? So here we have the actual, which is no default, and predicted no default. And then here we have the actual, default, and then predicted default. So here we are saying this person actually did not default, this person actually did default, and what is our model predicting this as? So here we have the terms over here, true negative and true positive. So these are very straightforward to understand. True negative is someone did not default in reality and we predicted they would not default, or the model predicted they would not default. This is really good. This is what we want. And true negative is on the opposite end, where someone did default and our model was able to capture that and predict that that person was going to default. So in the future, whenever someone comes in and has high risk of defaulting, our model is going to be able to pick out all those things over here. And false negative and false positive, as the name sounds, these are like wrong predictions. Someone did default, but then our model said they are not going to default over here. And someone did not default, but then our model said they are going to default. So that is false positive. So this is how to read the confusion matrix. And this is where it can become like an art to this data science, where, okay, we have the model trained, but then do we want to optimize for true negative or true positive? Which means if someone is not defaulting, do we want to catch more of those people in here? Or if someone is defaulting and our prediction is default, do we want to catch more of that? So from just looking at this, it seems like true positive is going to be the metric that we are most interested in, because if someone is not defaulting and if we don't approve loan for them, that is still fine. But if someone is defaulting and we kind of approve them because of false negative, that is bad for us, because that has implications application on the bank business, right? So we want to catch as many of the people as we want in this true positive, where if they're going to default, we want to name them as default. So this is the one we are most concerned in. So even if we have more true negatives, that is fine. Or if we have less negatives, true negatives, that's fine. If we don't give out loans, that's still fine, but we don't want any default. So that is how to read the confusion matrix. And I can just print this out. So these are all coming from sklearn. So we'll just import that and let's print out this confusion matrix. So here we have out of all people, so we have like 100 and 200. So this is all good. You can also print like confusion matrix percentages to understand this. But there is another one metric that we can use, which is like classification report, which we are just going to call and then look at what got. So we're getting some metrics like precision, recall, F1, support, etc. And these are accuracy metrics and other things. So this in conjunction with the confusion matrix that we saw is going to be really helpful in deciding which model to use. And I've got a simple example over here as well. Precision, what we see over here is just a true positive divided by true positive plus false positive. So when the model predicts default, how often is this correct? So this is probably the case that we want to have a good number of values. And then recall on the opposite end is true positive divided by true positive plus false negative. And of all the actual default cases, how many did the model correctly identify? So this is probably the one that we really want to care and get, because like we spoke about, if someone is defaulting, we want to capture them and correctly identify them as default. So if you look at the score that we have for recall, that is going to be the key for us. So here we are saying when someone is defaulting, we're able to predict them with 64%. So probably this is not the best model. So we want this to be really, really high. So if you think about this 0.7, which is the false negative, this is at 70% and this is at 65%. So these two, which we are most interested in, is not doing that well with logistic regression. And this is synthetic data anyway, but this is how you would go about understanding these. If you're looking for precision, this would be a really good one as well. But yeah, here it says 64%. So I'm kind of on the fence on this. But if this is the best model that we can get, I guess we have to try out other complicated algorithms. So hopefully this gives you an understanding of how credit risk analysis work and how to go about evaluating them. And more importantly, get an intuition of how classification works, because confusion matrix, classification report, precision, recall, and all these things are going to be common across any classification algorithm you would use. All that's different is how the regression or XGBoost and other classification algorithms have been implemented. So with that said, I'll catch you in tomorrow's data science project.